All right, we're still in lesson 7.7, and we're moving on to writing quadratics with different things. Do you like that? Things. All right, so let's talk about a quadratic function. We know a quadratic function is y equals ax squared plus bx plus c, but we were also given y equals a times x minus h quantity squared plus k. So they're telling us a few things. The first thing is we know there's a minimum value of -1. So when I graph this, I know at -1, somewhere on this line, is going to be the smallest value. So that's already telling me that it's going to be a positive a. So we do know that. I also know that it has roots of f of x equals 0. The roots are 1 and 3. How do I know that? Because it tells me that right here. Remember, x-intercepts are roots, which are also solutions, which are also zeros. So I know that we have x minus 1. You know what? Let me do it the way that we did it yesterday. We have ax minus blank x plus blank. If I add those together, I get 4. If I multiply those together, I get 3. All right, I know that this if I use x is equal to opposite of b over 2a to find my max or min, or even what we would call the vertex, I know the opposite of b is 4 over 2 times 1 is going to give me 2. So at this point, positive 2, and we knew the minimum was -1, we also know that the 2 points of my x-intercepts are going to go through 1 and 3. So because of over 1 up 1 over 1 up 3, my guess is that this is going to be a parabola just as we see. Sometimes I like to verify that this a is just equal to 1, so let's do that. An x-intercept is when y equals 0, so I'm going to put in the number 1 and 0 for my x. My h, well, my h is at 2 right here. This midpoint, this minimum is at 2, -1, plus k, remember that was my -1. So when I solve this, I get 1, -1 squared is 1, and 1 is equal to 1a, so a is obviously just equal to 1. So I can rewrite this just like I had it in orange. That doesn't work out always that pretty, so get used to that not always happening. X squared minus 4x plus 3. We're going to try one that's a little uglier. What if I told you that the vertex was at 212 and the x-intercepts were at -4 and 8? Well, remember, I know that an x-intercept is when y is 0, so I'm going to call it what it is, -4, 0. I'm not even going to use the 8. All right, let's plug it back in. Y equals a times x minus h quantity squared plus k. I know my y is 0. I don't know my a. My x is -4. My h is 2, and my k is 12. So when I solve for a, I get 36a plus 12, and I subtract the 12 over, and a is equal to -1/3, because -12 over 36 is -1/3. I'm going to put all this back into y equals a times x minus h quantity squared plus k, where my a now is -1/3. My y is going to be y, my x will be x, my h will actually be the number 2, and my k will be a 12. We have to FOIL this mess right here. Y equals -1/3. I'm going to do it in my head. X times x is x squared. The outers are -2x, inners are -2x, -4x. The last, -2 times -2 is +4. I have to distribute this 1/3 to all three terms, and I get y equals negative 1/3 x squared minus 4/3 x. Oops, that should be a plus 4/3 x minus 4/3 plus 12. And notice here I do have to add these like terms, so I'm just going to do that over here. Negative 4/3 plus 12, well 12 is 36/3. So that's going to bring me to my final answer of, and I'm going to write this as a function of x, negative 1/3 x plus 4/3 x plus 32/3. So when I add those, I get 32/3.